Welcome back. In this new video, we will be looking at the growth of combinations of functions. Now we will use different functions, we will combine them, and we will see how the growth of those individual functions can be used or translated into the growth of those combinations. Now, when we look at computers and computer programs, they contain many subroutines and many procedures are combined. Now, the total time that a program needs to complete depends on the time to complete all of these different procedures and subroutines. Now, when we want to determine the big O estimate of an entire program, it is important to determine the big O of each step and the combination of these different steps. And that's what we're going to do. We're going to look into some typical combinations, the addition of functions, and the multiplication of functions. Look at the general idea about big O for f1 plus f2, the sum of two functions. So from the definition, we state that f1, absolute value of f1 of x, is smaller or equal than c1, absolute value of g1 of x, for all x values larger than a k1, and we can say the same thing for f2, for values for x larger than k2. And now we can say that the function f1 is in fact big O of g1 of x, and the big O of f2 is in fact g2 of x. Now, when we look at both of the functions, we can say that the absolute value of f1 plus f2 is in fact equal to the absolute value of f1 of x plus f2 of x. And that's a relationship that we know. We also know from the triangular relationship, when we look at the absolute values, that the absolute value of f1 of x plus f2 of x is smaller than or equal to the absolute values of f1 of x plus f2 of x. So the absolute value of a sum of terms is smaller than or equal to the sum of the absolute values. Now, when x is greater than both k1 and k2, we can rewrite this inequality using the inequalities at the top. And what we can say that in this case, the absolute value of f1 of x plus f2 of x is smaller than the different functions, because we can add them into the inequality. We can replace f1 of x by c1 times absolute value of g of x. So because this is larger or equal than f1 of x, so basically we can write here that the absolute value of f1 of x plus f2 of x is smaller than or equal to c1 times the absolute value of g1 of x plus c2 times the absolute value of g2 of x. And we can say that this is in fact the sum of those two values, those two functions, can be written as c times the absolute value of g of x for x larger than k. Now, when we look here in the equation, we can say that c is equal to c1 plus c2. But for g1 and g2, we have to look at the maximum value, which is the maximum of those two. And in this case, we can say that g of x is then equal to the maximum of the absolute value of g1 of x and the absolute value of g2 of x. There is another possibility when we can look at f1 plus f2, and we can also say that in this case, when we have that combination, we have the combination that when we have f1 of x and f2 of x, f1 of x is O g1 of x, f2 of x is O g2 of x, and then we can say that f1 plus f2 of x is the big O of the maximum of g1 of x and g2 of x. Now, when both functions are big O of g of x, of course, then the maximum of g1 of x and g2 of x is g of x. And we can then say that the big O of f1 plus f2 of x is big O of g of x, because now g1 and g2 are in fact the same functions. It would be like we have a quadratic equation, two quadratic equations or two third-degree equations, then the big O for both of them would be the same. Let's have a look at a small exercise. We have f1 of x is x to the third plus 5x plus 2. We have f2 of x is x plus 1. We know that f1 of x is big O x to the third, and of 2 of x is big O of x. Now for f1 we can find c1 which is equal to 2 and k1 is equal to 3. So these are the witnesses to prove that f1 is big O x to the third, and for f2 of x we can find c2 which is equal to 2 and k2 is equal to 2. So that's also the witness, or those are the witnesses for big O of x. Based on what we found before, we can find the maximum of g1 of x and g2 of x, which in this case is g1 of x because it's x to the third. So basically we find that the element here is that the f1 plus f2 of x is big O of x to the third for x larger than 3. And that's in fact the thing for the addition. We can do the same thing for the product of two functions. So we find the definition. We consider f1 of x, f2 of x. f1 of x is big O of g1 of x, and f2 of x is big O g2 of x. Then f1 times f2 of x is big O of the product of those two functions. Now we can consider an example here. Let's consider that we have fx, which is x to the third times x plus 2. So we have fx1, which is x to the third, and f2 of x, which is x, is equal to 1. And basically on this we find here that f1 is O x to the third, big O x to the third, and f2 is big O of x, and we can write that the product of f1 and f2, saying f of x, is big O of x to the fourth power. So we saw in this video how to work with the combination of functions, how this impact the big O function, and in fact this was the last part, last video in this course about the growth of functions. In the next video we will be discussing the complexity of algorithms and how to deal with them when we are looking at solutions. You're doing a great job. I'm looking forward to seeing you in our next video. Thank you and bye-bye.